Hello, welcome to my channel. We will be doing question number 2 of chapter 16, I believe. Yeah, 16. Okay, so this is like an application of the calculus and all this concept. So part 1 of this question is that uh, a particle P moves in a straight line starting from rest. P moves with constant acceleration for 30 seconds, after which it moves with constant velocity k meter per second for 90 seconds. Okay, so you see it is 15. Okay, sorry, it is 30. Yes, for 30 seconds it moves with a constant acceleration. So since the acceleration is constant, its speed keeps on increasing linearly. Right, this is the speed. On the y-axis we are plotting the speed. Okay, now uh, after 30 seconds, it moved with a constant speed for 90 seconds, right? So this is 30 to 1, 2, 3, 4, 5, 6. So this is 90 plus 30, this is 120, okay? Okay, so this is 120. So up till 120, it goes with a constant speed, okay? So if we reach over here, okay, and then it says P then moves with constant deceleration until it comes to rest. The magnitude of deceleration is twice the magnitude of the initial acceleration. So it accelerated to this speed in 30 seconds. So if it deaccelerates with the twice the deceleration, then it will come to stop in 15 seconds only. So at 135, it will come down from K to 0. Okay, so this is the graph, and then it becomes like this. Okay, this is the straight line. I don't know if it lost straight line. Okay, now, so this is part one. Now, part two is that given that the particle travels 450 meters while it was accelerating, find the value of k. Okay, so this is the region in which it was accelerating. Okay, so remember that distance, right? This is okay. Sorry, derivative of the distance, like I call it s. So derivative of the distance is speed, right? So the integral of speed will give you distance. Okay, so if you want to find the distance, let me use s for the distance. So um, yes, okay. So we don't need to integrate particularly. Okay, but in general, yes, sorry. Distance as a function of time. This is the integral of the speed. Okay, and integral is the area under the curve. So if you find the area of this curve, that will give you the distance, right? Okay, now what is this area? The area of this triangle is 1/2, and base is 30, and height is k, right? And this is total area, and this is given by 450 meters. Okay, so from here I see that k is equal to this is 15, so k is 450 over 15. So this is going to be 30. Okay, and the units of k would be meter per second because it is the speed. Okay, so on y-axis and it is speed. Okay, so this was part uh, 2 of this question. A2. Okay, now part B, it says, this is another question. A body Q moves in a straight line such that t seconds after passing a fixed point, its acceleration is given by this much. Okay, so the acceleration as a function of time is given as 3t square plus 6. Okay, and we need to find the velocity. Remember, acceleration is the derivative of the velocity. Okay, so from here we conclude that velocity, if I want to find the velocity as a function of time, so that is going to be the integral of acceleration. Okay, so if I integrate the acceleration, I will get the velocity. Okay, so I need to integrate this thing, 3t square plus 6. Okay, and this would be 3 and t cube by 3 plus 6t plus a constant of integration. So this is going to be t cube plus 6t plus c. Just to double check, if I differentiate this thing, it will give me 3t squared plus 6. That's it. So that's mean this integration is correct. Okay, now we are given that when t is 0, the velocity was 5 meter per second. Okay, so I will use this information to find the constant c. So velocity is 5 when t was 0. So it is 0 plus 0 plus c. So my c is equal to 5. So the exact expression for the velocity as a function of time, it is going to be t cube plus 6t plus 5. Okay, now the last part is find the velocity when t is 3. So this is easy. We want to find the velocity when t is 3. So it is going to be 3 power 3 plus 6 times 3 and plus 5. This is going to be 27 plus 18 plus 5. And this all comes to be 50. 50 meters per second. Okay. So I believe it was an easy question. I hope you have no confusion or anything. If you ever have want to ask any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.